All right, good to have you all here. I'm hoping you're having a great trailblazer today. So, before I begin, a quick show of hands. How many of you here build packages for App Exchange? All right. And how many of you here have been through the security review process? Woo, okay. I'm sure you have a lot of experience to speak from that. I can't even attempt to talk about. However, I do promise that after this session ends, you will have a lot of new tools to use that can help you have a better head start when you go for your next security review process. And even if you're not an app developer, you can still get tools that can help you write clean and secure code. All right, everyone. I'm Rupa Mohan. I am a principal software engineer at Salesforce, and I'm one of the developers in the Salesforce Code Analyzer team. And today I'll be talking to you all about the tools we are developing to help you write secure and amazing code. As always, the forward-looking statement, please don't make any purchase decisions based on the contents of this presentation. This is the agenda I have planned for us. We'll first look at what the Salesforce Code Analyzer tool is, what it does, and then I'll be introducing to all of you the Salesforce Graph Engine. It's a brand new engine, and I'm really excited to talk about that here today. I'll also be giving you a demo on how to use all of these, and I'll give you steps to get started right away. All right. I think we can all agree on one thing. Early feedback makes life easier. So when we are developing an application, it's just good to have access to feedback right when we start off. We don't want to wait. In fact, even if we wait till QA, it would have been better if we had all of that information when we were developing the code. And the farther it gets, the more of a hassle it becomes. So in the spirit of this, if we look at security review process, by the time we go for that, we already have everything solidified, and it's just so much more of a hassle to make these changes. So what we want to give you, we want to empower you with the ability to find all of these issues yourself before you go for the security review, so that when you get there, you already have everything figured out, and it would be a lot easier, and that will be a lot less friction. That's exactly what we're hoping for. There is a tool out there that already does some of this. If you haven't heard about it, it's been open source. It's been available for 2 years now. It's free for all. So have you met the Salesforce Code Analyzer? It was formerly known as the Salesforce CLI scanner, so some of you may know it by that name. This is an open source plugin, like I mentioned, and it's on the Salesforce CLI framework, formerly known as SFDX. What does the Salesforce Code Analyzer do? It detects issues, like I said, and it focuses on languages that are mainly used by Salesforce developers because it's for us. And what kind of issues does it detect? So it detects security vulnerabilities, performance issues, and then generally anti-patterns in code that we know are going to be like creating errors for us later. So that's the kind of issues that it detects. And like any other SFDX plugin, it's just easy to use. It's a single line of installation, and then immediately you get going. We support many different output formats, so that depending on your use case, you have a format that supports what you need to do. Especially if you want to plug this into the CI/CD process, if you have an existing CI/CD process, or if you want to set something up, this is easily pluggable. It just fits right in. So what do we do for this actual analysis? Rather than reinventing all of this analysis, we are relying on experts to do the analysis for us. We have some really awesome engines in the backend. All of these are open source as well. I'm sure you have all heard of PMD. It's one of the best static analyzers, open source static analyzers out there, and it does a great job with so many different languages. It has an especially great support for Apex and Visualforce. We are really thankful to the community for how much they contribute. There is also ESLint, which is arguably one of the best linters for JavaScript. And it has great support for TypeScript, LWC, a lot of different cool extensions. And then there's Rittar.js. I'm not sure if many of you have heard of it, but this is also an amazing open source tool that can detect vulnerabilities on JavaScript dependencies that you have. So it's really cool. And then there is copy-paste detector from PMD as well, and they can detect all these large blocks of code that we copy-pasted and we forgot to refactor. So, and then there is another engine, SFG. I'll be talking about that. So what is the value from Salesforce Code Analyzer with all of this? So even though it's using all of these different tools in the backend, it still gives an experience of using a single tool. So we don't have the hassle of setting up all these different plugins, all these different tools. Instead, it's a single installation, single run, single output. All the different formats are quashed together. We have a single format to deal with. It just makes everything easier. OK, so I'm going to take a slight detour now. And let's talk about how exactly this analysis happens. I'm sure a lot of you are familiar with this. So the way this analysis happens, the way the analysis happens for, I should say, many common static analyzers is that it converts the code into a format known as abstract syntax tree. And then this abstract syntax tree is nothing but the building blocks that make a code. And it's kind of a hierarchy, so that represents the code. I'm sure you're all having flashbacks of your compile design classes. So this is really cool. It can handle a lot of common issues because a lot of these issues that we know about, they can be represented by a code hierarchy. For example, let's say we wanted to detect a performance issue wherein a DML statement is inside a for loop. That's it, it's code hierarchy. It's easy to understand. It's easy to predict using an AST-based analysis. And also, these are just so quick. They are so light on the resources that you can just run so much of analysis in a very short period of time. However, there are some coding issues that are not necessarily best solvable by AST-based analysis. I can give you some examples. So anytime you're looking at interaction between multiple classes, and then each of these classes are represented by separate files, it's not intuitive to use AST-based analysis to solve this. I mean, it can be done. It's kind of a stretch. And also, anytime the issue cannot be represented by a simple code hierarchy, it's going to get difficult. Let's say any issue which is not as simple as, I'll give you an example in a few minutes, you'll know what I'm talking about. But anytime it can't be represented by just a code hierarchy, it's not going to be easy. Also, when we have cases where there is a specific method which is behaving differently depending on the context in which it is invoked. So that could be a specific context which can create this issue, and another context does not create this issue. So let me give you an example to elaborate that better. I have a simple piece of code, and then this has a say hello method, and then it takes in a name. It says hello. And we have a string variable that's initialized to null. Not a good idea. Please don't do that. And then we have a condition on name. So if name is null, the string variable is going to be overridden by a hello name. And then we're going to print the string values lowercase at line number 6. Now, the AST looks at this piece of code. It converts this into a code hierarchy. And then OK, I should mention this. So the whole problem here is that we are trying to predict if this piece of code is going to throw a null pointer exception or not. As human beings, I'm sure we look at this, we know what's going on. But then the AST-based analysis looks at it. It creates a code hierarchy. It goes through the code hierarchy, looks at each line. There isn't much it can do, because it still doesn't know, it doesn't understand what a null is. Now, compare this to another approach called data flow analysis. Data flow analysis has this notion of building paths that traverse the control flow of logic. So it starts off, it creates these paths, and then it walks these paths. At every node, it attempts to make an educated guess on what the value of data is. So let's say data flow analysis approach is looking at this piece of code. It starts off with one path, and then this path starts off at line number 3. It sees a string variable that's initialized to null. So it keeps that, okay, I know you have a string variable that's initialized to null. And then it comes to line number 4. It sees that name has a check to see if it's null or not. Now it has no idea what the name value is because it didn't walk the piece of code that invoked this method. So it says, okay, I'm not sure what the value of name is. Let me first make an assumption that this condition is true. And so it goes to the next line where if the condition is true, the value of string is overridden. So that when it comes to line number 6, it knows that we are going to print a method that's invoked on string. So it's going to print hello name. Now, just because we saw a conditional, it creates a second path. This time, it again starts off with string variable initialized to null. And then as soon as it sees this condition, it says, OK, now I'm going to go through the case where this condition evaluates to false. And so it jumps directly to line number 6. You can't invoke a method on a null, and then you get a null pointer exception. I hope you understand the value that data flow analysis brings through all of this. I have obviously oversimplified it just to make this point get through. But this is what exactly we have implemented. So introducing to all of you the Salesforce Graph Engine. This would be the latest engine to join the backend of the Salesforce Code Analyzer. And like I mentioned, it performs data flow analysis on Apex. Now, when I spoke about paths, I obviously oversimplified to a conditional because it's just easy to understand. But anytime a method invocation happens, or if an object is instantiated, it invokes a constructor, which is also another method invocation. So all of these create new paths, and data flow analysis can understand all of this. So it understands when a class is instantiated, it knows that one object of a class is different from another object, and then it understands that variable scopes exist, so it knows that a class variable has more longevity than a block variable. It understands inheritance. There is a lot of things that it can do. It's really powerful, and it complements really well with the AST-based analysis. As a starter, we have implemented detecting CRUD-F-less violations. We just chose CRUD-F-less violations because it's one of the most common violations that show up during security review. So we want to give you that power. We want to make sure that when you go for your security review process, you have at least the CRUD-F-less violations figured out. I'm about to move into the demo. This is the agenda I have planned for us. So we'll be trying out the Salesforce Code Analyzer tool, see how it works, and then we'll deep dive into the Salesforce Graph Engine. And finally, we'll also see the Graph Engine catching CRUD-F-less violations. I just saved us a couple of minutes by doing the install already, but then that's the command you will use to install it when you try it out. All right, so demo time. Are you guys ready? All right, so what I have here for us, oh, okay, I'll be showing that to you once again. Here you go. I'll be giving you a newer command in a minute, though. All right, so demo time. So what I have here for us is a simple force.com app. It has all the usual culprits we know about. There is Apex classes, Aura components, Visual Force pages. Pretty much represents any typical force.com app. And as you know, it has all these different layers, so it has a lot of different languages that are being internally coded for. Now that we have done the installation, all we need to do to run it is sfdx scanner run, and then we provide a target. So what do you want to analyze? That's the target. So I'm giving all of the source directory. And then I'm also giving an optional out file. I'm giving this in HTML format. It supports many other formats, but just because it's a demo. So that's it. It's running. It's invoking all these different engines in the backend, and then it's collecting the violations for us. That's it. Finish running. Now let's look at the results file and see what we have. Okay, you can immediately look at the donut graph and get an idea on how your code is doing. There is one SEV 2, a bunch of SEV 3, and then a SEV 5. Not bad. What we have below that is the list of violations that were detected. You can see that all of these are grouped by the file on which it was detected. And you can also see which engine created these violations. So that way you know what's happening in the back end. And then if you look at an individual violation, you see there is a line number and column number to tell you where exactly this violation is. And finally, it has information on what this violation, most importantly, it has a link to information about this violation to tell you why is this even a violation, what is it we need to do to fix it. So that's the HTML output. What if you wanted to put this in your CI/CD? So this is not going to be very useful. Instead, what we support is a JUnit format so that anytime you see a violation, this violation is going to become a test failure, and that will block the build pipeline. It also has some ways to tweak it so that if you care only about Sev 1s and Sev 2s and not so much about Sev 3s, you can adjust that. You can set the severity threshold. I'm not going to run that for us now, but please look at our documentation. I'm going to switch gears now. We're going to look at the Salesforce Graph Engine. But before I do that, I just want to jog your memory. I'm sure all of you are experts here. But this is how a typical CRUDF list check looks. So if you're trying to do an insert on account, and then we are setting the name, the check would look something like schema.subject_type.account.fields.name.isCreatable. So isCreatable is for the insert, name is for the field, and account is the object. Internally, what this is doing is creating a describe result for an subject type, and from that it creates a describe result for the field, and then it does the isCreatable check. Apex has this really nice way to dynamically generate this. So if we pass the object name as a string and field name as a string, we can use the getDescribe method to do all of this. Now, this code is too simple. I'm not going to show a demo now on this code, though I do want to point out that as developers, we want to make the best use of this. We try to separate all of this. We break it down into the business logic and the actual utility to do these checks for us so that our code is clean. There is great cohesiveness, there is low coupling, all of that. What I do have for us today is a real-life example from NPSP. NPSP is the non-profit startup pack from Salesforce Foundation. I'm sure you've heard of it. And here, what they have is a really complex system to do their CRUDF list checks. So they have a util permission. So this util permission is a singleton. And this singleton has a lot of methods to do the actual check. So there is a can read, can create. All of these are separated out. And internally, each of these checks rely on another utility called util_describe. And this util_describe does some really fun caching. So the first time we look up for an object, it's going to go do the highly intensive lookup, because there are like so many objects to look up from. It gets the describe result of the object, and then it caches it, so that next time all we do is just reuse the same thing. It does the same for field describe result as well. Now, I don't expect you to understand the logic that's going behind this, but I just want to make sure you get the complexity of all of this that's happening. There are multiple singletons in play, and there is caching. There is a lot of things that's not typically done. Now, for our example, I have a much more simplified demo example, which internally uses the util permission and the util_describe that we just saw to does the CRUDF list check. So we have this demo example, which has a verify creatable method that we just spoke about. And then there is also a create information method. So this is an aura enabled method. It takes in a first name and last name. It checks if we have the CRUDF list access, and then it goes, creates a contact, and inserts it. Let's say we're given a user story where we want to add another field to this. So let's say we are asked to add a phone field, and then we want to include that into our contact. So the way we do it, we add that to our signature, and then we add that to our contact. All right, now that we are done, our user story is done. There is already a check happening somewhere, so we should be technically safe. So if we try to run the Salesforce Graph Engine, so this is how we'd run it. So we do sfdx, scanner run, DFA, and we provide the target, which would be, we can directly target it at the demo class we are looking at. And we also need to provide a project directory, because remember, we built all these paths. We need the context of where this is, we need to know about other classes to analyze entry points in demo example. So for that, we can just give the current directory. And this time for output, I'm going to give us CSV format, just because we want to try out another format. All right, that's it. So we're running this. It's building all the parts that we spoke about. And then it's taking the entry point as create information, and then it's looking at all of that. OK, so it's detected a violation for us. So let's open the CSV and see what the violation is. Let me actually open it on a spreadsheet for us. OK. So as you can see, it detected a violation for us. And then if we look at what the violation is, it's complaining about missing FLS validation check on phone field with the insert operation on contact. If we go back and look at the code, we were supposed to have this. But then if we look at it, there's a fields to check, which did not include the phone field. And obviously, that was missed. Now, if I rerun it, it's going to fix it for us. I think that kind of gives us the value. Now, let's say, what if we already knew that we don't need any of these CRUD-FLS checks because this page is already under a lot of permissions, so only an admin can look at this, and they have all the access rights. And so, as developers, we know that this doesn't need a CRUD-FLS check. So how do we tell that to the graph engine? So you can do that. Oops. You can do that by giving an engine directive. And this engine directive looks something like SFGE disable. We want to disable the rule that we don't want this to run for. So that is the Apex FLS violation rule. That's it. So this time, I hope I got it right. OK. So this time, if we try to rerun it, we shouldn't see any violations. This can be done at multiple levels. So you can do it for the class. You can do it for the specific. Oh, looks like I messed up. Sorry about that. OK. Demo snag. Anyway, so the point I'm trying to make is this is not just for the class level. You can put it for individual entry points. You can put it for exactly one insert. So it has a lot of control. And as you see, no rule violations found. And even though I'm giving this demo for describe result, this is also working for strip inaccessible or with security enforced. A lot of new things that are coming up. Some of them are already there. The pilot ones are not here, of course. But that's the demo I have for you. So let's quickly switch back to the slides. Now, this was the install command I showed you initially. This is the stable version that's already there. It's been around for 2 years, and it has many of the engines that we spoke about. However, if you want to use the latest pilot tag, that's going to get you the newest version of Salesforce Code Analyzer. And even though it doesn't include the SFG yet, we're going to include it in a couple of weeks. So I would say I'd highly recommend you to try the latest pilot. Be ready for it. In 2 weeks, we're going to get the Salesforce Graph Engine. So be there, try it out. Let us know what you think. And most importantly, here is our documentation page. So go have a look at it. Let us know your thoughts. So look for all the documentation. It has a link to our GitHub repo. Give us your feature requests, your feedback. We'd love to hear from you. And most importantly, watch out for the announcement on the release of the Salesforce Graph Engine. All right? That's pretty much all I have for us today. Thank you so much for your time. I wish we had more time so I could have spoken about many more features that we have. But please do take a few minutes. Go to your mobile app for the Trailblazer. Let us know your thoughts on how you like this, what you'd like to see next time, and take the survey. And thank you so much for your time again, and have a great rest of Trailblazer. All right?